All right, how about the second page? Now you've got your graphing function. So this is the part that you will start with. You will start with the question that gives you the graphing function and then asks for all the parts of it. Domain, range, increasing, decreasing, max, min, zeros, value, and then even, odd, or neither. That all those parts are based on a graph. Yep.
How do you figure out if it's even or odd?
So if you're looking at the picture, you're looking to see if it's symmetric to the y-axis. Can you fold it right on that y-axis? If you're or if it's origin, it would be like top right, bottom left, top left, bottom right. Like you could fold it down and then over and have it overlap. If you're looking at the equation, then you're looking to see if I plugged in a negative x, does it go away? So if I plug in a negative x in place of all these x's, this one doesn't go away. This one does. This one changes sign. And obviously there's no impact there. So I would plug in a negative x. If everything goes back to the original, then it's even because it's symmetric to the y-axis. If every single term changes signs, then it's odd because it has symmetry to the origin. So this time it was neither. Your graph is neither. If you look at your function, you can't fold it along the y-axis and you can't fold it diagonally. Yeah.
With increasing, decreasing, and constants, do we ever put brackets?
The only time you would ever put a bracket is if it started all the way on the left or ended all the way on the right with a solid dot and it was horizontal. That's the only time. Every other time it's parentheses. So increasing and decreasing intervals, never brackets, because a point cannot be increasing, a point cannot be decreasing. But it can start constant. It can't be, if it's shared by 2 points, we can't put a bracket on it. If it's like in the middle and it's changing from constant to decreasing or constant to increasing, that point's gonna get a parentheses. But if it physically starts, like if this guy had a horizontal segment over here on the left, then that very first point would have a bracket, which won't happen from your calculator. Could happen from a piecewise function if you graph it, but that wouldn't happen with your calculator. We haven't even talked about how to graph piecewise functions on your calculator, so it wouldn't happen. All right, then we got into the actual chapter 1. So 1-1 was all the lines. 1-2 started your function notation. Any questions on this page? Okay, we get into continuing 1-2. Now we're evaluating piecewise functions. We're finding the domain. You're finding the difference quotient. Any questions on those? Again, difference quotient, the more comfortable you are, the faster it's going to be, the less time you will waste on that kind of question. Then we got into 1-3, which is the right side of this page. 1-3 was finding domain and range from a graph. Finding, determining if it is a function from a graph, finding your increasing and decreasing, your max and your min, and then sketching the graph. So I would say questions like 55 all the way through to the 73, those types of questions will be one question with multiple parts. So instead of it saying, what is this part, what is your max and min, what is your increasing, decreasing, all of that is put together in the one question. That's the graphing one. Sure. Yep. As long as it's not multiple choice. There's only one question that's even multiple choice. Well, 2, I guess, if you give the even and odd. Like those things you won't get. But all the open-ended ones, you'll get partial credit. And then the sketching of the graph. So make sure, again, you can sketch a piecewise function by hand and then use it to answer questions. On questions 97, 99, 101, and 103. In the instructions, I had crossed out use the function notation to write in terms of the parent function. That is on as part of your test. So pretend like it's not crossed and make sure that you add that stuff. And then I just added this to the solution so that they're down there on the bottom. All right, then came 1-4. Well, the top of this is 1-3, which is the even and odd. And then came 1-4. So the right side of this is what you're ignoring. The right side of this is 1-5, which we did not get to yet, so you don't have to worry about it. We'll get to that when we get to the AP content. It's like in Unit 2, I think. You're good? Yes? All right, so The domain arrows bottom to top mean all real numbers and range all real numbers, but we're going to put it in interval notation to negative infinity to positive infinity. It is, once I label the max and min, so I would label max and min before you get to increasing and decreasing. Once I label that, then I know it's increasing on this curve, which is from negative infinity to negative 0.285. Then it changes to decreasing from that negative 0.285 to positive 1.303, which is the next min, and then it increases from that 1.303 to positive infinity. So you'll give me both those, or all three of those intervals. The relative max, it happens there at the top. It was negative 0.285 and 7.410. The relative min happened on the bottom, 1.303 and negative 4.008. It crossed the axis 3 times, which was negative 1.2, no, negative 1.218, 0.32832, and 1.613. This graph does not have y-axis or origin symmetry, so it's neither even nor odd. And then your f of negative 1.6 should have been negative 16.340. Yep.
For the zeros.
If I were to put like negative 1.218 comma 0, would you give myself for that?
So I probably won't if you keep it in parentheses, but I will tell you that I don't know if the AP would or not, because zeros mean what are the values of x in which f of x is 0. So if it doesn't say the word intercepts, you don't want to put it in coordinate point form.
All right.
Okay. All right, then the second one was your piecewise function. So yes, it looked weird. It was intentional. You had a y equals 2x minus 3 for your first one. If I drew that line out in its entirety, it would have started at 3, and it would have gone down 2 to the left 1 or up 2 and to the right 1, and your graph would have looked like this. But you only wanted to keep it for where it was less than negative 2. So the negative 2 point should have an open dot, and then it would have pointed to the left with an arrow. Then now that we're more comfortable with the parent functions, hopefully that helps with your quadratic there. That is a parabola that is reflected over the x-axis, and that is shifted up 1. So we shifted up 1, and it would be reflected over the x-axis. So it would have looked like this if it was the full parabola. But it wanted it only where it was from 0 to 2. So 0, I knew it's at 1. That one was because easy to find. And then I go down 1 into the right one because there's no stretch. But then the next one, if you don't know it off the top of your head, obviously you would take and plug that point in. If I plug 2 in, and I did this also intentionally, be really careful with these signs. Negative 2 squared plus 1 means I square the 2 first. That should be negative 4 plus 1, which is negative 3, and that's that coordinate point. It doesn't include it, so it's an open dot. So then my domain, if I go from left to right, is going to stop and start. It starts at negative infinity. It goes to negative 2, and then it stops. It gets a parentheses because it's an open dot. Then it picks back up at 0, and it goes to positive 2. The 0 is a solid dot. The 2 is an open dot, so the 0 gets the bracket. The 2 gets the parentheses. My range goes from negative infinity up to the first y, which is here. And that was negative 7, open dot, so it gets a parentheses. Then it stops and starts again at negative 3, open dot, so parentheses. And it stops at 1, closed dot, so it's a bracket. It is increasing on that first little interval. It had positive slope, so it was increasing from negative infinity up to the x there, which is negative 2. And then it changes to decreasing from 0 to 2. Ignore these relative max and mins. Again, you won't get something that the minimum is caused by a restriction on the domain or the maximum is caused by a restriction on domain, because we haven't had that conversation, so I don't want to confuse you, okay? It only crosses the x-axis once, and it is at 1, so that's your 0. It is neither even nor odd, and f of 1 is 0. You can find that value 2 ways. 1, look at your graph. 2, go up to these and say 1 would be in the range that is between 0 and 2. So if I plug in 1 there, I'd get negative 1 squared, which is negative 1 plus 1, and that's 0. So you can even check that answer using your intervals that are given, the equations that are given. Questions? Yeah, this is on the video. 2, I will post it on the review assignment. So anything we do review extra will go on that review assignment. All right, I have a Kahoot. I'm gonna make it like a Kahoot homework as an optional thing. I'm not gonna try to slam it in now. If you've done the review, the extra review, and you wanna do some questions, that's a great other practice. Your test is not multiple choice, okay, obviously. So it's not indicative of the type of question, but at least you can get some extra practice in there. So my advice this weekend is if you have not finished the review, do the review first. And then maybe Monday, as it's closer to your test, I always get nervous doing it after a long weekend, but I have no choice. Like, we have to do it in order to move on. So maybe Monday, do the extra review. And then if you've got time, work on that Kahoot, okay? But they are important questions, but this is a small portion of your test. So make sure you spend some time on the other stuff. Questions?